Welcome to my class introduction. Class standard 11. Subject higher mathematics first paper. Chapter name matrix and determinant. Exercise 1. Lecture 5. Today's lesson. Definition of determinant. Determine the value of determinant. Explain minor and cofactor of a determinant. Prove and apply fundamental properties of determinant. Now definition of determinant. That's mean the determinant of a square matrix A equal to this of order 2 or 2 by 2 because number of row and number of column are same. That's mean 2. So order of this matrix, that's mean A is 2 by 2, or we can say only 2 is determinant of A. This is a determinant symbol, that's been enclosed by 2 vertical bar. But for matrix enclosed by 2 square bracket or 2 curve bracket or 2 pairs of parallel lines, but determinant only 2 vertical bars enclosed by 2 vertical bars. That's the determinant of matrix A is this, and this equal to we can write like this way. That's mean enclosed by 2 vertical bar, and its value A11 into A22 minus A21 into A12. Clear? That is, a determinant is a square array of the number of perfect square quantities. Perfect square quantities mean, follow here, this is a square matrix of order 2. That's mean number of row 2 and number of column 2, and total entries or total quantities 1, 2, 3, 4. 4 is a perfect square number. Or when you will take a matrix of order 3, 3 means number of row and number of column are 3. So the entries or quantities or elements will be 9. This is a perfect square number. Similarly, when you take number of rows, column, number of rows 4 and number of columns also 4. So total entries or element or quantities will be 16. This is a perfect square number. Clear? Enclosed between 2 vertical bar. That's this and this. For example, here given some quantity 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a perfect square number, and number of rows 1, 2, 3, and number of columns 1, 2, 3. That's mean of third order. That's mean order 3 is a determinant of order 3. Okay, when number of rows and columns are 4, then order will be 4. Similarly, number of rows and columns are 5, then order will be 5. Clear? Minor and cofactor of determinant. Follow the definition. The determinant obtained with the elements of a given determinant D by omitting the row and the column which pass through any element is called the minor of that element in D. For example, the minors of A11, A12, A13, that is the minors of 1th entry, 1 2th entry, 1 3rd entry in a determinant. 1 1 mean first to first column, 1 2 mean first to second column, 1 3 mean first row third column. The entry lies on first row third column, first row second column, first row first column. That's mean A11, A12 and A13. This is a determinant. Okay. A11, that's mean minor of A11. This equal to, we have to omit the row and column which pass through this element. That's mean the row this and the column this passes through this element. So we have to omit this and this. So remaining these 4 elements. Okay. So the determinant of this 4 element is the minor of A11. Okay. Similarly, the minor of A12 will be A21, that's mean A21, A23, A31 and 3 because we have to omit this column and this row because this row column and this row because we have to omit the rows and column passes through this element. So this row and this column passes through this element. So we have to omit this row and this column. Again follow this row and this column. Remaining element, this 2 and this 2. So the determinant of these 4 elements, that's mean A21, A23, A31, A33 is the minor of A12. That's mean 1 tooth entry. Similarly, minor of A13 will be A21, A22, A31, A32. Okay. So determinant of this 4 element is the minor of A13. Okay. As here is total number of entries 9. So here we'll get total 9 minors. Okay. Similarly, when find the minor of A33, we have to omit this and this and remaining these 4 elements. So determinant of these 4 elements is the minor of A33. Or when we'll find the minor of A32, we have to omit this column and this row. Minor will be A11, A21, A13, A23. Okay. Minor of A32 will be this 2 and this 2. That's mean total 4 elements. That's mean determinants of these 4 elements. Okay. And like as we will find the remaining entries of this determinant. Clear? Okay. But follow here. Here sign plus, here sign plus, here sign plus. That's mean all the sign are same. When we will attach the sign of each minor, then it is called cofactor. But what will be the sign? When will be plus sign or when will be minus sign? Okay, now follow the definition of cofactor. A minor of an element with proper sign attached is called the cofactor of that element. That's mean the sign of the cofactor of R mean number of row, C mean number of column. Is that's mean RC entry will be minus to the power number of row plus number of column of any entry. Okay, such as the cofactors of 1 entry, 1 entry, and 1 entry, and 1 entry follow here. Here r plus 1, that's mean 1 plus 1. R plus C mean number of column. Here R mean 1, C mean 2. So 1 plus 2 for this entry, and for this entry will be minus 1 to the power 1 plus 3. That's mean number of row. First always row and second always column. That's mean 1 plus 3. So when we'll put here 1, here 1, we'll get 1 plus 1. That's mean 2. So power of minus 1 is equal to 2. 2 mean even. When the power will be even, then we'll get sign plus. That's mean minus 1 into minus 1. Minus 1 into minus 1 mean plus 1. So sign will be plus. But when you'll put 1, that's mean r is equal to 1 and c equal to 2, we will get 1 plus 2 equal to 3. At power of minus 1 is 3. As the power of minus 1 is 3, so sign will be same. That's mean minus. Why minus? Because minus 1 into minus 1 into minus 1 will get minus minus plus, plus minus minus. Similar way, when here will be 5 will get minus, when here will be 7 will get minus. But when the power of minus 1 will be even, sign will be always positive plus. As again follow here number of row 1, number of column 3. So 1 plus 3, this equal to 4. 4 mean power even, so sign will be plus, because minus 1 into minus 1 into minus 1 into minus 1. So minus minus plus, again minus minus plus, plus plus will get plus. Clear everyone? Follow. Minor of a1 on this, but with sign, with proper sign, this is a cofactor. Here will be plus sign, because a1 mean number of row 1, number of, that's number of row 1, number of column also 1. So 1 plus 1 is equal to 2. So minus 1 to the power 2, this equal to plus. So here sign plus, here sign minus, because 1 to entry mean this entry, number of row 1, number of column 2. So minus 1 to the power 1 plus 2, this equal to minus 1 to the power 3. Minus 1 to the power 3 mean minus. So here will be sign minus, and here will be sign plus. Similarly, for this entry, cofactor will be minus, because here 2 1 2 plus 1 mean 3, but for this will be 2 plus 2, that's mean 4. This is plus, this is minus, because 2 plus 3 mean 5 minus. So sign for this cofactor will be minus, for this cofactor will be plus, for this cofactor will be minus, for this cofactor will be plus. So sign rule will be plus minus plus minus plus minus plus minus plus. Clear everyone? This is a cofactor. Similarly, for remaining entries, we can find the cofactor. We have find only for 3 entries. Okay. Also, you can find for this entry, this entry, this entry, this entry, this entry, and this entry. That's mean total here 9 cofactor. Clear? Okay. The value of determinant. Follow here. If the elements of any row or column, you can take any row or any column, no problem, of a determinant are multiplied by the corresponding cofactors of the elements. and the sum of the products is added, the value of the determinant is obtained. Again, follow the definition. If the elements of any row, that's mean you have to take any row or any column, no problem, but you have to multiply the cofactor of corresponding entries or elements. That's mean when you take this row or this column, you have to find the cofactor of a1, a2, a3, and then you have to multiply a1 into the cofactor of a1, a2 into the cofactor of a2, and a3 into the cofactor of a3, and added this, you will get the value of this determinant. Or you can take this along this row, the entries are a1, b1, c1, or you can take along this column or along this row, any row or any column, no problem. Here we have taken first column, that's mean a1, a2, and a3. In a determinant, this are a1, a2, a3. The cofactor of a1, this equal to, we have to omit this and this, so determinant of this, and the position of a1 is first row and first column, that's mean minus 1 to the power 1 plus 1, so here will be plus, and this is a second element of first row, the position of this entry, number of row first second, that means second row, and number of column 1, so 2 plus 1 mean 3, minus 1 to the power 3 mean minus, and the position of this element third row and first column, that's mean 3 plus 1, 3 plus 1 mean minus 1 to the power 3 plus 1 mean plus. Okay, that's mean follow next line, a1 into the corresponding cofactor of a1, this equal to b1, b2, c2, b3, c3, that's mean this, and a2 plus a2 into minus because the position of a2 is second row first column, okay, minus of this, plus a3 into this, we have already discussed this is a required value of the determinant. Clear everyone? Find the value of the determinant. The value of the determinant, this is 1 into product of the cofactor of 1, that's mean you have to omit this and this, will get determinant of this is the cofactor of 1 plus 4 mean this, and the position of 4 is second row first column, so here will be minus, and we have to omit this, and this will get the determinant of 2, 3, 8, 9 is the cofactor of 4. Similarly for 7 we'll get cofactor this. Now calculate value of this determinant, will get 5 into 9 minus 8 into 6 plus 4 into minus this mean minus 2 into 9 minus 8 into 3, and similarly here we'll get this. Now calculate, we'll get this result, and this finally will get 0. This is a required answer of this determinant. Clear everyone? Another process, expansion of determinant using Serre's diagram. Okay, Serres is a mathematician who used this process, so this is called Serres diagram. For expanding the determinant This, the Serres diagram is as follows. That's mean at first you have to take all the elements. That's mean this 3 column. Again repeat, you have to first 2 column. Okay. Now indicate along this line, this line, this line, and then indicate this, this, and this. At first you have to multiply this, this, and add it. Okay, then minus, and you have to multiply this, minus this, and this. Follow here, you will be clear. Okay, that's mean a1 a2 c3 plus b1 c2 a3 plus c1 a2 b1 minus a3 b2 c1 minus b3 c2 a1 c3 a2 b1, and we'll get the required result. This is another process. You can apply this, okay, for determine the value of determinant. Same math, but we have to use Serres diagram for expanding the determinant. This, the Serres diagram is as follows. At first you have to take same, then again repeat this 2. As a result, we will get 1 into 5 into 9 plus 2 into 6 into 7 plus 3 into 4 into 8 minus 7 into 5 into 3 minus 8 into 6 into 1 minus 9 into 4 into 2. Now calculate, we will get this minus this, and finally 0. In both case result 0. Okay, that's mean the process is correct, no problem. We can apply this. This is the required answer. Now assessment. Find the value of this, find the value of this. Okay. Now fundamental properties of determinant. If all the elements in a row or in a column are 0, the value of the determinant is 0. Here the entries of first row are 0, so value of this determinant is 0. Here the entries of first column, this equal to 0, so entry or value of determinant is also 0. Not only first row or first column, for any row or any column, here the entries of third row are 0. This is also value of determinant 0. Okay, or the entry of second row are 0, the value of this determinant also 0. Similarly here also, if the entry of second column are 0, the value of determinant is also 0. Clear? If the rows are changed to columns and columns to rows, the value of the determinant is not altered. That's mean transpose of a determinant and original determinant are same. Okay, here given our original determinant, and after interchange rows and columns we will get another determinant. Here this is a column, but here this is a row. Here this is a column, this is a row. Here this is a column, this is a row, but value will be same. That's mean this and this are same. Clear? The interchange of any two rows of a determinant changes the sign of the determinant. That's mean after interchanging any two rows or columns, the value of the determinant will be same but sign will be opposite. That's mean this is a given determinant. Here this is the first column, but here this is a second column, here this is a second column, here this is a first column. That means change only these two column. As only these two column, so sign will be changed. That's mean opposite, negative. Here plus, here will be minus, but value same. Clear? If two rows or columns of a determinant are same or identical, that is, if ratios of corresponding elements of any two rows or columns are equal, the value of the determinant will be 0. Follow here. First two column, this and this are same, so the value of determinant is 0. Here ratio of first two column are same, that's mean this is to this, that's mean this by this will get m, this by this will get m, this by this will get m, so the determinant will be 0. Okay, here this by this or this by this will get m by n or n by m, here m by n or n by m, here also m by n or m by n, same. That's mean value of this determinant is 0. Remember this, okay? If every element of a row or column is multiplied by any scalar, the value of the determinant is multiplied by the scalar. That's mean when you multiply a scalar quantity of any row or column, this quantity multiply the determinant. That's mean a equal to this. When we'll multiply m, any column, that's mean first column, the entries of first column multiplied by m, will get ma1, ma2, ma3. Okay, that's mean this scalar, that's mean a multiplied the determinant, that's mean this multiplied the determinant this, and this equal to a, so this equal to, we can write m into a. But for matrix, when we multiply a scalar quantity of a matrix, this quantity multiply all the elements. But for determinant, this scalar quantity multiply any number of rows or any number of columns, no problem. Here first column you can multiply second column, or you can multiply third column. That's mean this quantity, this scalar quantity multiply the determinant. Clear? 6 number, if each element of any row or column of a determinant is increased or diminished by any equal multiples of the corresponding elements of another row, the value of the determinant does not change. Follow here. This is the original determinant. When you multiply these entries, that's mean entries of second column by the scalar m and added to first column, and again the entries of third column multiplied by n and subtract from second column, you'll get another determinant, but value of this and this are equal, no sense. Okay, will be same. Clear? And finally 7 number, if each element of any row or column of a determinant is expressed as the sum or differences of two quantities, the determinant can be expressed as the sum or difference of two determinant of the same order. Okay, that's mean this is a given determinant, this equal to, we can write at first we have to take this part, that's mean this part and these two parts same, these two parts same, and same similarly remaining xyz and this part same. Okay, this is a determinant of order 3, this equal to, we can write 2 determinant, but order of this is all this 3, and also order of this is 3, that's mean order same. Clear? or we can write along row here a1 plus x, b1 plus y, c1 plus z. This equal to, we can write a1 a2 a3. That's when you have to take this element, and this element, and secondly we take x y z and others. That means second row, third row, second row, third row, same. Okay, the order of this matrix is 3 also, this and this 3. Okay, but result will be same. Determinant of this and determinant of this plus this are same. Okay, today up to this, but this lecture is very important for you because you have to know all the properties, all the definition of determinant that are important for you. Okay, and this is a basic knowledge of determinant. Okay, if you will capture easily, you can solve the math. Remember this. Now homework. Make an assignment on the lecture. Submit date of submit 12/7/2020, time 9 p.m. Okay, thank you all everybody.